morning everyone, this is AGM. Today we are going to see some image formation through spherical mirrors. Before that we already studied in a previous class the ray diagrams where this is the principal axis, this is the pole, focus and center of curvature. When a ray is incident parallel to the principal axis, it passes through focus in a concave mirror. So when a ray is incident on focus, after reflection it will be parallel to the principal axis. The law of reversibility of light. Here parallel to principal axis it is passing through the focus. So when a ray is incident on the focus, it will be parallel to the principal axis. So law of reversibility of light. Okay. Next, when a ray is incident through center of curvature, okay, without any deviation, after reflection it passes through same path. When a ray is incident at the pole, after reflection it follows the laws of reflection of light. So now coming to ray diagrams through convex mirror. Convex mirror is a diverging mirror. When a ray is incident parallel to the principal axis, after reflection it diverges, but when we extend it, it appears to pass through the focus. So when a ray is incident, it appears to pass through the focus. After reflection it will be parallel to the principal axis. As I said, this is a law of reversibility of light. Okay, when a ray is incident on a convex mirror, as it appears to pass through the center of curvature, after reflection it passes through the same path. When a ray is incident at the pole, okay, it reflects and follows the laws of reflection. So now we will see the image formation with respect to the object. This is a concave mirror, converging mirror. When the object is kept at infinity, we know that at infinity we cannot see. That's why it is a dotted line. After certain distance we can see. That's why these are the full lines. So whatever the imaginary lines, suppose this is the principal axis which is represented by our dotted lines. So principal axis, which is used for reference. So now when I keep the object at infinity, so the rays are parallel to principal axis. After reflection it passes through the focus. When the object is at infinity, image formation takes place at the focus. Now we will discuss some points. Position of the object is at infinity. Image formation takes place at the focus, which is highly diminished and point size. So nature of image is real and inverted. So now coming to the object is placed behind the C, because when I kept object at infinity, now I am moving the object towards our pole. So next case, when the object is kept behind C, so we need minimum 2 rays, and where 2 rays are meeting, there will be image formation takes place. Okay. One ray is incident parallel to the principal axis, it passes to the focus. Another ray is incident through the focus, after reflection it will be parallel to our principal axis. Here 2 rays are meeting, so this is the image formation case. So when the object is kept at infinity, image formation takes place in between C and F. Now we will see some point behind the C, image in between C and F. And nature of image is real and inverted. The size is diminished or a small size. When the object is kept, in the last case we see behind C, we will keep the object at C. So one ray is parallel to the principal axis. After reflection it passes through the focus, and another ray is incident through focus. After reflection it will be parallel to the principal axis. Here we can see the size of the object and image same, and the image is inverted. Okay. When we keep the object at C, image formation is also takes place at C. So we will see some points. Object is at C, image formation is also at C. Nature real and inverted, ulta hai. Size same size as that of the object. Okay. Now coming to another case. So we kept at C in a last case. Now we will move the object in between C and F. When the object is kept in between C and F, the object is kept in between C and F. One ray is incident parallel to the principal axis. After reflection it passes through the focus, and another ray passes through the focus. After reflection it will be parallel. here two rays are meeting. So when the object is kept at a C, so image formation takes place between the C, which is real and inverted. The size of the image is greater than the object. Object is kept in between C and F. Image formation between the C. Nature real and inverted. Size is enlarged. Now coming to when we kept an object at a focus, the image formation takes place at infinity because these rays never meet. So when an object is at F means focus, the image formation takes place at infinity, which is also real and inverted, highly enlarged. Now coming to the final case, when the object is kept F and P, in between F and P. So I will send a ray from the center of curvature. So it will, after reflection, it will pass through same path. And another ray I will incident at the pole. So it will reflect and follows the laws of reflection. These rays are not meeting. When I extend this backward, these will meet in the mirror. Here when the object is kept in between F and P, image formation takes place in the mirror. We can see which is virtual and erect and enlarged. This is the only one case in a concave mirror when the object is kept in between F and P. Okay, image formation takes place within the mirror and the nature is virtual and erect. Size is enlarged. We can remember simply that when the object kept in between F and P. So we know that pata poster nikla here. Okay, from this we can remember. Now coming to another two cases. Convex mirror. Here this is a diverging mirror. When the object is kept at infinity, when the rays are parallel. After reflection, these are the diverging. When we extend it backwards, it meeting at F. So here object is at infinity. Image appears to be means we are purposefully meeting. When we extend the line, it is meeting at the focus. That's why image appears to be on a focus behind the mirror. Nature is virtual and erect. Size is highly diminished or a point size. Next case, when we keep an object in between infinity to the pole. So infinity to the pole means we can measure. We can keep anywhere on the center of curvature or behind the center of curvature. So we can measure this distance. When the object is kept in between infinity to the pole. So the image formation takes place behind the mirror, which is of small size, virtual and erect. So these are the image formation through convex and concave mirror, and we can remember very easily that in the first case, when the object is at infinity, image is at a focus, and the opposite of that one is when the object is at a focus, image is at a infinity. Okay, when the object is at behind C, image is in between C and F. Okay, in between C and F. When the object behind C, image is in between C and F. When the object is in between C and F, ulta, object is behind C. So only one case we can get image size and the object size is same. So when the object is at kept C, the image formation takes place also at a C of a same size. And another thing, in a convex mirror, you need a virtual image, means we should keep the object in between F and P. So these rays are not meeting, we will extend backwards. So the image is virtual and erect enlarged. This is the only one special case we can get two types of images. So in a convex at infinity on the focus, and you keep in between infinity to the pole, the image will be behind the mirror, which is virtual and erect. Thank you. Please subscribe and share. Namaskar.